question pattern has not been changed widely. So yeah, every year the pattern of the question changes a little bit, but it's not varied widely. Okay, so you can guess that if you can solve the previous year problem thoroughly, all the previous year problem like last 10 years, like in each year there are two exams for the next year. So if you can solve like all the problems, all the classical mechanics problem from all the like previous 10 years question paper, then most likely you'll get there is a question in the upcoming year that will be in the same pattern. Okay, so this will help a lot in preparing for the NET and GRF June 2021 or 2022 if you are targeting. All right, so first we'll look at the first problem, and the first problem is saying that a particle of unit mass is moves in a potential of Vx equal to ax square plus bx square, where a and b are the positive constant. The angular frequency of the small oscillation about the minimum of the potential is this. What will be the angular frequency of the small oscillation? We need to find out the value of the omega. Okay, so we need to find out, I'm sorry, it's not working somehow. So we need to find out the value of omega. Okay, one sec. I don't know exactly why it's not working. So let me just refresh again the OneNote, and then we'll look at the problem for the very first problem. So yes, no, I don't want optional data. All right, so let's see now. For example, if I take white pen, so yeah, it's now working. So we need to find out the value of the omega. Now what is the formula we have to find the value of the omega? So the formula we have in our hand, that is omega equal to √4 of k by m. Now what is k? K is the spring constant and m is the mass. Here mass equal to 1, because I can say that this is a unit mass, and the value of the k, we know that the value of the k is basically double derivative of the potential at the stable unstable fixed point. Okay, so basically fixed point in the value of the k is basically d2 v dx2 at the fixed point. All right, so now we want to find the derivative of the potential that is given is ax square plus b by x square. All right, so if you do the first order derivative, okay, dv dx, it will come 2ax plus b minus 2x by x to the power 4, and it will become 2ax minus 2b by x cube. Now you have to find the stable fixed point. What you need to do, we need to just equate this first order derivative, that is the tangent of the potential along the x axis, or the rate of change of potential with the x equal to 0. So this will become like, I'm sorry, 2ax equal to 2b by x cube, and we will end up getting the value x to the power 4 equal to b by a, and this will x equal to b by a to the power whole 4. All right, so now we got our stable fixed point. If we know our stable fixed point, then what we can do, we can find the value of the k by putting the value of d2v dx2. Okay, so this derivative will be 2a minus 2b minus 3x square by x to the power 6. So this value will be 2a plus 6b by x to the power 4. All right, so now here you can see that if I just plug in the value here, okay, so d2v dx2 at the point x equal to x naught, this will become 2a plus 6b x to the power 4 and 2a plus 6b by b into a. So we just plug in the value of the x to the power 4 here, and it will become, that is 8a. Okay, we got the value of the 8a, and that is the basically value of the k. Now we intended to find the value of the omega, and omega is equal to √4 of k by m. So here omega, I can see that omega equal to √4 of, in place of k we can write 8a by 1, and that is equal to √4 of 8a, and I can see this is the right answer. Okay, this is the right answer. All right, so let's move on to the next problem. Approximately 2.6 times that on the surface of the Mars, given that the radius of the Mars is about 1/2 the radius of the Earth. The ratio of the escape velocity on the Earth to that on Mars. is approximately. Okay, so acceleration g on the surface of the earth is approximately 2.6 times. So 2.6 times g in the earth by g on Mars is equal to 2.6 times. All right, so 2.6 times. Now, the given that the radius of the Mars is about one half radius. So if I talk about the radius of the earth by radius of Mars, so radius of the Mars earth is twice, right? Given that the radius of the Mars is about one half, so that is re by rm equal to 2. Now the ratio of the escape velocity on the earth to that on the moon, so escape velocity we can calculate in terms of v escape is equal to square root of 2g into r, right? So v e versus v Mars, that will be square root of 2gr by square root of 2gr, right? That is the ratio we want to find. Now the 2 they will cancel out, and ge GE So GE, what is the value of the GE by GM? GE by GM equal to 2.6. Okay, and the RE by RM, that is 2. Okay, so this will become 5.2. Okay, square root of 5.2. So what is the value of a square root of 5.2? Square root of 5.2, this will be like 23, 9, 6. So this is 9 to 529. Okay, so this value is approximately, you can see that this value is approximately the r to the mass is approximately, so here it is given approximately. So whenever you will attempt this kind of problem, try to look at what is asking, because the value is not value will not come exactly, because you can see that this is 5.29, right? So it is the answer is coming 5.2. So in this case the approximation, if you apply, okay, so if you apply the approximation, then this answer is correct. Okay, for the approximate answer we are talking about. Okay, so this is very tricky one. Why this is tricky one? Because everyone knows the formula, but the answer will not come immediately. So that's why I need to find out whether the approximate answer is coming close to the actual answer or not. Alright, so now moving on to the third problem. The Hamiltonian of a system with n degrees of freedom is given by h equal to q1, q2, q3 dot dot qn, p1, p2, p3 dot dot tn, and the time. So with an explicit dependence on the time t, which of the following is correct? Okay, so now here if you can see which of the following is correct. So here you can see that Hamiltonian has the time dependence. Okay, so if the Hamiltonian has the time dependence, then which one of the following is correct? Different phase trajectories cannot intersect each other. So different phase trajectories cannot intersect each other. This is a very true statement. That is definitely is true. The trajectories cannot intersect each other. H always represents the total energy of the system, and it is a constant of motion. It is H not always represent the total energy. This is basically a constant of motion, that is true, but H does not always represent the total energy of the system, because total energy of the system is an invariant quantity. It does not matter which phase you are going through, that is total energy always remain conserved, but that is Hamiltonian is always remain conserved, but this is not the case always represent the total energy. This is not right. All right, so the equation qi dh dpi and pi dot equal to dh dqi are not valid, since age has explicit time dependence. It is not true. This formula is valid when the time dependence is there in the Hamiltonian. Okay, so this is also not true. So any initial volume element in the phase space remains unchanged in the magnitude under the time evolution. So if you look at this last statement, any initial volume element in the phase space remains unchanged. Okay, so what what is the volume represent in the phase space? If you just look at this one, so the volume of the phase space is basically number of the points they are residing inside of the phase space, right? So the number of the points is basically indicating the number of state. Okay, so when any system is undergoing time evolution, though, so any system is undergoing the time evolution, the number of available state will increase definitely as it is moving forward in time. Then number of available state will increase. হ্যালো, এই বলছি আমি তোমাকে একটুখানি পরে ফোন করছি, ওকে? 30 মিনিটস ম্যাক্সিমাম একটু কাজ করছি। হুম। So when we okay, so when we move forward to the time, then the available number of states, they will increase, and so the volume element in the phase space, that will also increase, and this is remains unchanged, it is written. So it is also not true. So the true one is this. Okay, so the phase space trajectories cannot intersect each other. Okay, so that is true statement. All right, so moving on to the next one. The Lagrangian of a particle of charge E and mass m in applied electric and magnetic field is given by L equal to half m v square plus E a dot v minus E phi, while a and phi are the vector and the scalar potential corresponding to the magnetic and the electric fields respectively. Which of the following statement is correct? So the canonically conjugate momentum of the particle is given by P equal to mv. That is, we need to calculate. We don't know that, and we cannot say this one is right or wrong. The Hamiltonian of the particle is given by this. This is the Hamiltonian. So we need to find out the Hamiltonian from the equation, the relation between the Hamiltonian and Lagrangian. So that is also we need to calculate. We cannot say that abruptly. And L remains unchanged under the gauge transformation of the potential. We also need to look at the gauge transformation equation, so that we will be able to say that this one is remain unchanged or not. So under a gauge transformation of potential, L changes by the total time with derivative under the gauge transformation. Okay, so if you look at the gauge transformation, there is a term that is dl dt. We know that, right? There is a term dl dt. So under the gauge transformation of potential, L changes by total time derivative. That is true. That is true. This one is true statement. For the gauge transformation, we have one dl dt inside of the gauge transformation. Without any calculation, we can say that I don't know about the option number 1, 2 and 3, but I can say that option number 4 is definitely, that is correct. Okay, so this is definitely correct. So I can just take on option number D, and just move on to the next question, so that we will be able to save a few time. Okay, so in the time of exam, during the time of exam, other than we need to calculate, if you cannot just find out which one is correct, other than you need to calculate all this thing, and it will take a hell lot of time. It will eat all of your time. Like, yeah, it is time consuming if you try to find out the value for the conjugate momentum, if you're trying to find out the value of the Hamiltonian. Okay, so we need to move smartly in this case. All right, so moving on to the next problem. Consider a decay process where a tau particle is decaying, and it is becoming 1 pi and negative, and the 1 neutrino, tau neutrino, in the rest frame of tau particle, negative tau particle. The masses of the tau, pi and tau neutrino are m tau, m pi and 0 respectively. Number one, the question is the energy of the pi particle is, in order to find the energy. Okay, so basically from the energy conservation law, we know that. What is the energy conservation law? So we have studied the energy conservation law. If there is any particle which is decaying, all right, so any particle, let's say for example tau, it is decaying in the pi minus plus neutrino, tau neutrino. So if it is decaying, so it has only the rest energy, right? So the rest energy, because it does not have any kinetic energy initially, because it was in rest, equal to the rest energy of pi minus and tau neutrino. Okay, so that means the rest energy m, should I write it in terms of m? Yeah, rest energy, I should write first in the theoretical form. The rest energy of pi plus rest energy of tau neutrino, okay, plus the kinetic energy of pi, kinetic energy of pi, and kinetic energy of tau neutrino. Okay, so this is the equation. And if I know that the masses are the masses of the tau, pi, and neutrino are m tau, m pi, and 0 respectively for the neutrino. Okay, so if you write in terms of the m tau c square, the rest energy is equal to the rest energy of the pi particle, that is m pi c square, and this value is 0. It's saying that 0, so this is 0. Okay, and the kinetic energy is not given, right? So the kinetic energy is not given, k pi plus k neutrino. Okay, this is the equation. Okay, so from this equation we need to find out the energy of pi minus particle. Okay, so how can we find the energy? So energy has equation E equal to p square c square plus m naught square c to the power 4. Okay, so for the pi e pi, that is what we need to find out. P square c square plus m naught square, in place of m naught we should write m tau, m naught square c to the power 4. That is first equation. Second, E neutrino. Okay, that is basically it will become p square c square plus 0, obviously, because this mass is 0 is given. So if we talk about and say this equation, this m tau c square, from this equations, like I can write this equation as in this way: E of pi minus equal to E of total energy. I'm writing sorry. E of tau minus equal to E of pi minus plus E of neutrino. Okay, that is the first equation I should have been written in this form. So I know this value separately. And okay, so let's find out what is the problem here. We need to find out the value of the e pi minus, right? E pi minus, that is the value we need to find out. So we need to find, we can see that the answer there is only m. Okay, so we need to eliminate any of the pc or this kind of thing we need to eliminate. Okay, so in order to find this answer, what we need to do first is the okay, so square this one, take this equation 1, take this equation 2. Okay, so square this equation 1 and 2, square this equation 1 and 2, so that e pi square minus e tau square, and this will basically p square c square plus m pi square c to the power 4 minus tau square equal to p square c square. So this will become m pi square c to the power 4. Okay, so I can write this equation I can write in terms of e pi minus plus e neutrino and e pi minus this equation in terms of the e neutrino equal to m pi square c to the power 4. Okay, so now here from this equation I can get the value of e pi minus e neutrino, minus value I can find out by m pi square c to the power 4 divided by e pi plus e neutrino. Okay, so this value you can see that this value is easily we can get from this equation, that is basically m tau c square. Okay, so I can write m pi square c to the power 4 by m tau c square. Okay, so this equation will become uh, m pi square c square by m tau. Okay, so this is the value of the minus, okay, minus e pi minus tau. And if I want to find the value of the e pi from these two above equation, if I want to find out the value, then how can I do that? Let me write plus value is given, plus what is the plus value, plus yeah, so basically e pi minus plus e neutrino, this is equal to m tau c square, and e pi minus of e neutrino, this is basically m pi square c square by m tau. So if I do this, then add these two, e pi minus is equal to m tau c square plus m pi square c square by m tau divided by half. Okay, so divided by half this, so I can write from this equation is equal to, if I take out common c, m tau plus m pi square divided by 2 m tau. Is there any option? Let me see. 2 m tau, and here we have 2 m tau and c square. There is a minus sign, but is there any problem that I have made? That is the calculation is yes, there is a calculation mistake I have done here. The calculation mistake is this. So when I'm adding this quantity here, so definitely this will be yeah, sorry, I'm sorry, there's a calculation mistake. This will be e pi minus equal to, let's take a different color, e pi minus equal to m tau c square plus m pi c square by m tau. Okay, and this is 2 here we have. So here m tau square, right, m tau square plus m pi square common, this is c square by m tau, and the e pi equal to 2. Okay, so option number B is the right option. Okay, so that is the mistake I have done, so I'm sorry for that. Yeah, this is the right option. Okay, now the velocity of the pion, the velocity of pion is, what is the velocity? Now we need to find out the velocity found from the equation, the previous equation what we have just derived. The e pi equal to, we have found out m tau square plus m what is that, m pi square. Okay, so m pi square into c square. So this is a very bad handwriting, I'm sorry for that, I'm really sorry. So this is m pi and c square by the 2m tau. Okay, this energy is equal to the m pi c square by square root of 1 minus v square by c square. So we need to find out the value of this v square and c square. So how can you find that? You can find easily by squaring these two equations on the both side. So what you need to do is m tau square plus m pi square square c to the power 4 4 m tau square is equal to m pi square c to the power 4 1 minus v square by c square. Okay, so from this point you can solve this equation. It's not that very difficult. So 1 minus v square by c square take out, and the rest of the equation is uh, m pi square c to the power 4 into, that is 4m tau square by m tau square plus m pi square uh, square c to the power 4. All right, so from this equation also you can find out the value of this equation. And what I'm doing, basically I'm taking out this one. So m tau square plus m pi square whole square c to the power 4 minus, right, so minus m pi square c to the power 4 plus 4m tau square divided by m tau square plus m pi square whole square c to the power 4. All right, so it is equal to v square by c square. All right, so we are getting towards our desired value. You can see that, right? So m pi square c to the power 4, and this calculation is, a little bit lengthy, so I don't like the calculation, so I hope you can do it by yourself. The answer is most likely, I don't need to know exactly what will be the answer, but I hope that you can solve the rest of the problem, so that I am leaving the problem right now. And if you cannot solve the problem, just give me one comment down below, so that I will solve this problem for you. Okay, so if you cannot solve this problem, okay, because I have shown you how you can approach the problem, but this is not everything. You need to solve the problem till the very last line, so that you can write the answer. So it's a kind of a lengthy problem, so that's why I'm leaving right now. I'm leaving right now. Okay, so my cat is disturbing me. All right, so the Hamiltonian of a particle of unit mass moving in the xy plane is given to be h equal to xpx minus ypy minus half x square minus half x square. Okay, so minus half x square plus half y square is in suitable units. The initial value are given to be x0 y0 equal to 1 1, and p0 x0 and y0 equal to half minus half the duration of the during the motion, the curve stressed out by the particle in the xy plane. Okay, so this is basically, you need to find out the solution of this equation, so that you can find out the curve in the phase space px py. So you have to find out the value on the px py, that means phase space trajectory in the xy plane. So x px and y py, what you need to do, you need to find out the equation. Okay, so the equation, what we know, like in the previous problem, we have seen this formula, right? This formula, I can see that this one, q dot equal to dh dpi and p dot equal to dh dqi minus, there is a minus sign during the time when we are finding p dot. So q dot means here x dot equal to dh dpx, okay, and y dot equal to dh dpy. That is the first set of equation. The second set of equation are this, uh, p dot equal to minus dh dx px we are talking about, and py dot equal to minus dh dy. All right, so now we need to find out this value. Okay, so how can we find out this value? In order to find out this value, what we need to do, h we have, so exactly we can do the x dot. So x dot, what is x dot? The x dot, sorry, this will be y, so x dot will be dpx, so we are doing x, and there is any px we have, No, nothing. So dpx, this is the value. Okay, now y dot is equal to, I can see the dpy in respect to dpy, so minus y, minus y. Okay, and the px dot is equal to minus of ddx. So I can see here is x, we have this is x here, so this equation will be a little bit lengthy in terms of the quality. Okay, so take the green color as I'm following the trend. Okay, so px dot is equal to with respect to x, or with respect to x dot, with respect to x, no, let me confirm the formula. Yeah, with respect to x. So with respect to x, when we will try to find, um, this will be minus px, obviously, second minus of half into 2x. Okay, which will end up giving us a value x minus px. Okay, and py equal to minus, this will become minus py plus half into 2y, and this will end up giving us the result py minus y. All right, so this is basically four differential equation we can see. So this four differential equation, if we can just write it down, this equation is dx dt is equal to x. Okay, the first equation. Second equation is number one. So how can you solve this equation? So this is very easy. So dx by x equal to dt, and this is the solution. That is ln x equal to t plus c, and the second equation is also given, that is dy dt equal to minus y. So if you take the integration on the both side, it will become dy by y equal to minus dt. Okay, so this is ln y equal to minus t plus c2. Okay, the first and the second equation, differential equation, we have solved. The third one is this, dpx dt equal to, let's take out minus common factor, minus px minus x, there is a minus. Okay, so what we'll be doing, we'll take the integration, or we can write dpx by px minus x, take the integration, and dt integration. So this will become ln px minus x equal to t plus c3, and the last integration is this, number 4, is the dpy dt is equal to the py minus y. So dpy by py minus y equal to dt integral, and if we do the integration, that will become ln py minus y equal to t plus c4. Okay, now your task, what you need to do right now is the find the value of the constant c1, c2, c3 and the c4, and this value you can find easily from the boundary value condition. The condition is given px py half and minus half, and the at x equal to 0 and x equal to 1 1 1 during this motion. So that is you need to do, and that is your homework. You need to solve this problem. Then if you are able to find the c1, c2, c3 and the c4 from this above given equation, you need to find out the relation between the x and the px and y and the py. So if you are able to see that x and the px, what will be the relation between x and the px, if you just find out the the value. Okay, yes, if you find out the value, most likely it will be parabola. Yeah, most likely it will be parabola. Just see, just check this one, all these values, this value of c1, c2, c3 and the c4, and if you just plug in the value of the x and y from this equation you can get the equation, and from this equation also you can get the equation of the trajectory. Okay, so this is if the equation become like x into px equal to some constant, or y into py equal to some constant. This is basically xy equal to constant, and this equation will be like a parabola. So parabolic equation will be there most likely, but even before you do that, you need to find out the boundary value condition apply, and then see what is there in the equation of this four equation. Okay, that is by yourself you can do it, I hope. So that's all for today. So today we have discussed what we have discussed today. We have discussed different kind of classical mechanics problem which used to be asked in the year of 2011, and there are five types or six type of problem we have discussed today. Our goal is to find like a different kind of problem every day, from the classical mechanics one day, in the very next day we'll be doing the quantum mechanics, in the very next day we'll be doing the statistical mechanics, and one upload every single day. If you are practicing with me, like wise in which direction we are going, definitely I can guarantee you the selection